Okay, so we've moved on from organic chemistry, and as you can see with Monday it said begin the sugars. So this is a different type of chemistry known as what?
Organic.
Biochemistry. That's right. So what that means is obviously, well, I wouldn't say obviously, but what we mean is you're combining some biological processes along with the chemistry behind it, hence the name biochemistry. So we began with sugars. So what is everything that you can tell me about what you have learned about sugars in our biochemistry portion? They're not good for you? They are monosaccharides because what are 3 of the monosaccharides we have discussed? We actually discussed 4, but you're responsible for 3 of them. No. You got the right idea, but you're not in the right aspect. Okay, so you said glucose, fructose, and galactose. Okay? You're getting a little ahead of yourself over there. Okay? What you mean is these. Okay. So, for instance, if we were to look at this, this is a Fisher projection formula, and even if we did not go any further, is there something specific, 2 things that, I'm sorry, I sound like a little hoarse here, I know, probably sounds off pitch. Why is that important? True, but what we mean by that is, notice the difference when we had seen this. So yes, there are some aspects that are in common. There's probably a good idea. Yes. Okay. They each have 6 carbons. Okay. But as far as a functional group, how are they different? See, we're applying some of our organic chemistry to some of this biochemistry. So what we mean by that, as opposed to right. So when we look at the difference between these two, the organic family on the left is a what? Aldehyde. The organic family on the right, ketone. So then that's where we get aldose and ketose sugars from. Because on a ketose sugar, or with that of a ketone, that double bonded oxygen is located anywhere except what? The end, or the first one. So if it's on the second carbon, that makes that a ketose sugar then, just like this makes this a ketone. All right. So there's 6 carbons in each compound, okay? And this is a hexose. This is what we consider as being it's a ketose sugar, but the trick is how many sides would this monosaccharide have? Okay, how many sides would this monosaccharide have that, now trick question, that has 6 carbons though? It's only got 5, okay? Pretty important distinction. Okay, so then once we start switching this up, so which monosaccharide would that be? It's one you don't have wrote down. I was just seeing if we're awake out there. Okay. The only one for certain we can leave is that one. Okay? So, glucose or galactose? Because you have it wrote down already. Okay, so if we're doing galactose, then you would need to do this, correct? Okay. Then one of the things that we see happening hopefully your drawings are a little better than mine. Okay. Then what do we have to have significant on that?
You gotta have that double bond.
Mm-hmm. Maybe. No. Not a double bond.
Just the regular bonds.
Okay. So do you want an OH group above or below?
Below.
Okay. All right. So here's carbon 1. Right here is carbon number 1. Carbon 2, the OH is on the right side, so what does that tell you? Carbon number 3, the OH is on the left side, so what does that tell you? Okay. Okay. Then for this one, carbon number 4, it's on the left side, so if 3 and it's up, then this is also on the top. And then there is your molecule of something galactose. Because of what you chose on carbon number 1. Why is that right? Because we chose this to be down. Okay, so that makes this alpha. We're not too concerned about the D, but alpha D galactose. And then for those of you who decide to punish yourself, I like to say punishment, next year. Okay, who wants to punish themselves next year? Well, it's not really punishment. What would this have to do with next year?
More complex.
Mm-hmm. Because we make the transformation we start drawing these in a chair formation, and that's how you would refer to them in college. We want you to get a head start on that. And that is really tough to do. Okay? So that's why we spend a little bit of time on it, because we're trying to describe to a separate class, okay? Believe it or not, but we are on your side. We do want you to be successful, okay? It's how we go about getting to that point. Okay, so then very quickly, what side of figure is this fructose here?
5.
Okay, it's a 5-sided figure, and this is where they begin to differ. Okay, because carbon number 1 is not here like it is in a hexose. This is actually carbon 2, so then where's this first carbon then? Can be.
On the other side.
Technically, yes. You're not wrong, but they're actually in both spots, okay? Because you have that molecule here and that molecule here as well. So therefore, do you like this funny looking fish shape or ribbon or whichever?
Yeah.
Or would you like that guy?
I like that guy.
Let's do that guy.
Do that guy, okay. So then that means this is up there because carbon number 1 is right there, okay? Carbon number 2 is where this reduction took place. Carbon number 3, which is right here, so that's up. Here's carbon number 4, that's down. And if we want to put these hydrogens in, we can and or should. And then in this case, this is actually up top. There is your beta D fructose.
The alpha's better than the beta.
Okay, can be.
The alpha would just be what?
Then if this is alpha D fructose, this OH is down, CH2OH is up on top.
And the other side would stay the same though.
This would stay the same. That's right. See, I like how we're gaining this information, so we're plugging our ear so it doesn't fall out, right? Okay. Yes, I've noticed you've had that up for about 5 minutes now. All right. Okay. So, moving on then. Is there any questions upon this? Okay. This is just a quick summation, if you want to call it that, or quick, what might be another word for that? Review, maybe? Review. That's right. Well, we've already done that. Okay. So then maybe some of you are still drawing that. Okay. So it looks like we're going to be here tomorrow afternoon, everybody, correct? Okay. Well, yeah, well, we hope not, and we hope we don't have to hear that siren go off that if there's a tornado here. I mean, this has happened long before your time, but there, on the national news, we have seen tornadoes hit school districts, and sometimes not everyone walked into school fine, but not everybody walked out fine. It happens. Okay? We just hope it doesn't happen here. We have no control over it. We just do the best we can to survive in that manner. Okay. So, amino acids.
Is there actually supposed to be a tornado?
I don't know. There could be a slight risk of that.
It's like 40-mile-an-hour winds today.
Okay? So now, what can you tell me about amino acids from yesterday? Do these have anything in common?
Yeah.
They do.
They all have an E.
Well, yeah, that's true. Right. So then your amine group is this. Okay. And then this is your acid group. Okay. So, glycine, alanine, or valine? Pick one. Okay? So, if we're going to make valine, what specifically do we need to put down here?
Need a V.
Okay? You know, oddly enough,
Isopropyl.
I like that answer better. Okay? But you're, okay, we're close. That would be your valine structure. Okay? Would it take a lot to change this to alanine?
No.
What do we need to do? Now you've got alanine. Okay? Can we make this to glycine pretty easily? Now we've got glycine. Okay? So again, these patterns, they continually do repeat themselves. All right. Moving on down the line. Just keep on going in the same direction. Okay? So with these are both 4-carbon derivatives. This one's a 3-carbon. These are both 4 carbons. So what that means then, okay, then this is where you'd place that 4th carbon. Then we're going to use logic to help you keep these separate. So again, this is the leucine amino acid. And we can convert that to isoleucine really quickly. I'm just showing you that so then you can see that it's different. Now we've got isoleucine. When we're talking about isoleucine, this is on the second carbon. If it's leucine, it's on the third. Okay? So alphabetically speaking, those are your two amino acids. Of course, we know our alphabet. The only thing that you really need is a 4-carbon derivative. Alphabetically, what comes first? So that means since isoleucine comes first, the methyl group goes on the second carbon. If it's leucine, that comes after isoleucine. Now it's down here in the middle. That's the only thing that separates these two. That's it. Trying to give you some tools, tricks of the trade, which, by the way, did you learn anything? Were you given tools and tricks of things like that for your tour yesterday? Did
Yep.
students,
Yeah,
were they able to give you any insight on that?
yeah, they were pretty helpful.
Okay.
They were giving some tips.
Mm-hmm. All right.
I know it.
So then, you know what?
So I know a guy there. I know him too.
All right.
He's a good buddy of mine. I used to sit.
All right.
He used to sit in Showbox. No, it wasn't the Showbox. It was where they do all their surgeries. He was the operator in the ER. He's in the ER working for
There's a reason that we're putting a box around that. Okay? Okay? This is now methionine. Okay? And if we were to refer to last year, biology here, okay? And the reason we put a box around that is as follows. Boy. I'm looking for something very specific. I know I'm standing right in the way. Who do you trust the most in here?
myself. Caitlin.
Okay? What does that say right there? Underneath there. Methionine. Okay? Methionine is. Oh, so should we give you some of these terms to read then too?
Yeah, bring it over here.
Hmm.
Bring it over. He's in my best shot. He's gotta find the hardest one.
No, you seem to think that this is just so simple. Mm-hmm. All right. I lost track of it. Yeah. That one right there.
I could even see it.
Oh, I thought this was so easy.
You got the book away from my eyes and the thing.
Okay.
Which one? This one?
Uh-huh.
Alanine.
Oh. It's not as simple as it seems. I thought it was called alanine. That's what we called it.
That's right.
Right?
Let me try. What the
All right.
we work in?
So, the reason that this is significant is, okay, this is how we teach it at the next level. Okay? How many curves are on this S? 2, right? So you can use that to help you saying, well, we need 2 carbons and then 1 at the end. That's just what I do. I don't know if there's something that you can do to help yourself. That's just how I look at it.
Are we gonna do
Cysteine. We actually did that yesterday.
We only did 3.
Oh, we didn't do cysteine. Oh, okay. My mistake, your fault. Okay. So, St. Peter's Basilica. Does anyone know where that's at? It's in Rome. Did you know the largest church is in the smallest country in the world? What does that mean to you? The largest church, the Catholic Church, is centered, not just Rome, it's in a separate country in Rome. No. You're starting to try to say it, yes. Vatican City is its own country. So isn't that rather ironic? The largest church is centered in the smallest country in the world. Okay? So if you were to be a tourist in St. Peter's Basilica.
So you're telling me to start looking into smaller cities?
No, that's not what we're saying.
I'm looking for the big ones.
Does anyone know it was Michelangelo painted something really specific in St. Peter's Basilica? No. That was Leonardo da Vinci. They're only separated probably by, 700 years, but I don't know. They're not separated by that far. Okay, so St. Peter's Basilica. It was something chapel. The Sistine Chapel. So, if you are walking through to view the Sistine Chapel, someone might say, shh, it's the Sistine Chapel. So therefore, we just put another sulfur on there, then a hydrogen. So you go, shh, we're watching the Sistine Chapel. I don't know, it works for me. Okay?
That's all it is?
That's all it is.
Pretty simple. Can we write that on the test?
I'm going to go with
Just
no.
when your friend needs help with that one, you can just
Yeah.
Oh, see, I never even thought of that. Okay? So, one of the things we're trying to tell you, we're trying to develop this program that we have here. These stars and asterisks, that's what the freshmen are learning, these top 3. This one, probably this one too, but at least the top 3. Okay? We're adding 4 more for you to know. Then, should you decide to take the biochemistry portion, then we're up to, that's 8. Then there's 5 more after this one for you're responsible for knowing. We're trying to scare you away, so otherwise, see, that's why that class size is so small. We scared everybody away. All right. So, therefore, in the good book, organic and biochemistry here. Okay.
Hey, did you, Commissioner McKenna, did you see Biden yesterday? He was reading his script. Can you
I-
guys quit making fun of him?
I don't know what we're talking about.
He said 4 more years, pause. Like he was supposed to pause, but he read it off the sheet as pause.
Oh,
That's a mistake.
okay.
I meant to do that.
Let's see here.
Like what?
Yeah, that is my president, guys.
What did people do to him?
Yes.
Yeah, okay. So this is the table. It has all the different amino acid structures. See?
Yeah, that's light work. Yeah.
One of these is cysteine. Is it this one? No,
Yeah.
top one.
The top one.
Okay? So, one carbon. See? One carbon, one sulfur, one hydrogen. So that's the way you say, shh. It's the Sistine Chapel.
Yeah.
Yeah. Okay? All right. That's the general direction that we're moving. So I think I've had enough of talking for now.
Mr. Mechanic, did you record for third hour?
There was nothing to record because of that. Now, okay, that's all I have. We'll move on with this next time. We'll probably be in the lab tomorrow. We'll do a process called esterification. Okay, we could say it's a complex process, but what's unique about it is you take what we know of as, okay, if you had to guess ethanoic acid, what is everything you can tell me about ethanoic acid? Right, true. Anything else you can tell me about ethanoic acid? So let's put this to use. You said this, okay? Is there anything else you can tell me about ethanoic acid? Someone said it, I don't know. What'd you say? 2 carbons. That's right. Okay? Some people call it acetic acid. Some people call it ethanoic acid. And other people might use this as a cleaner for windows, vinegar. Okay? This is vinegar as well. Okay? Then, if you take this organic family, no, you don't need to write this down. What organic family is this? Yeah, I know it is one of them. That's why I'm asking you.
I'm asking you just in case you don't know.
This is called methanol. So then now that gives you a clue. It's an alcohol. So what happens is it's called intramolecular dehydration. Okay? That's a $50 word, I know. So if this gets stripped off of there, what do you see inside those 2 boxes if you put them 2 together? Water. You're taking H2O out of this. So then this combines to form a more complex compound known as an ester. Esters give off fragrances. Just like if you bite into an apple, an orange, a grapefruit, banana, strawberry. In this case, it's wintergreen, I believe. So it's a complex process that you perhaps complete tomorrow. Okay. So we'll catch up to you next time.